Hi and welcome back. In this video on image classifier using SVM, we are going to look at the road signs classification problem that we are going to solve and something called as feature descriptors, and specifically the histogram of oriented gradients descriptor. We'll also implement this process using an SVM in JavaScript. We'll make use of kernels and see what my output looks like. The problem that we are going to solve is the identification of road signs. We have different road signs over here like indirection, obligation, danger, and other signs. Our task is to identify, given an image, which of these categories it is. The dataset that we are using is obtained from this address. Now our task is of image classification, but we cannot use the actual image as an input to our machine learning algorithm. For this, we have to use either the pixel intensity or some other form so that the image is represented in a form where my algorithm can understand it. We have noticed that pixel intensity does not work well for algorithms other than neural network. So for this particular case, we are going to make use of histogram of oriented gradients feature descriptor. This technique basically counts the occurrence of gradient orientation in localized portions of an image, which means it takes batches of the image and counts something called as gradient orientation and then makes a histogram of it. To get a better understanding of what histogram of oriented gradients or HOG features mean, you can search this online. But for now, this much information that it transforms our original image in a feature matrix is sufficient to solve this problem. Now let's look at the SVM code to actually implement image classifier in JavaScript. Now let's look at the code. Here, I have opened my section 4_3. In this folder, I start with an npm init. Next, I open this folder inside my Visual Studio Code. Here, I have a few files. I have a folder called data, which contains all my images. Then I have a CSV with the test data and another CSV with the training data. This data is nothing but the file name along with the label, the file name and then the label. Now let's see our index.js code. Here, I start by importing all my necessary libraries. An fs library which is going to be used for reading the file from the file system. HOG features library which is going to use to create my HOG descriptors. Image.js file. libsvm which is an improved version of the SVM library. ml-kernel and a range library. Next, I create a function called options which contains my values for my options for my SVM. The type of the SVM that we are selecting is NUSVC for support vector classification. Next, we tell that we are using a pre-computed kernel. The degree of the kernel is going to be 3 and where shrinking is false, which means that at each step we are not shrinking the number of steps. Next, I create my options for my HOG. The cell size is 4, the block size is 2, the block stride is 1, the number of bins in the histogram is 6, and we are using the L2 norm. Next, we create an empty set of arrays xtrain, ytrain, xtest, ytest, ktrain, and xtrain. We are going to use these variables to store my x features and y labels. Then we are going to use ktrain and ktest to store my features after applying the HOG descriptor. We start by making an async call to the function loadData. Inside loadData, we create two functions, loadTrainingSet and loadTestSet. Inside loadTrainingData, I read my labels train file. I use filesystem.readFileSync and then convert it to string and split it for each new line. So now my variable lines contain all the lines in the data. We iterate over the length of the lines, which is the number of lines in the data, and for each iteration, we split the line on a semicolon, and we store the splitted array in elements. If the size of the elements array is less than 2, we skip that iteration. Then, we create a variable file and store the location of the file using the file name. We read that file into image. We scale that image to a size of width 100 and height 100. We then apply the HOG feature descriptors and store the output in a variable called descriptor. We then push the descriptor into the xtrain array and push the label into a ytrain array. Next, we create a new polynomial kernel with a degree 3 with a scale of 1 by the length of xtrain. Then we apply the kernel on top of xtrain and store that result in ktrain variable. Similarly, we have a function load test set. Which does pretty much the same except that it stores the value in ktest, and we are reading the labels test.csv file. Once load data is complete, we can now start building a classifier, training it, and then testing for results. We start by initializing the SVM into a variable called classifier. We then train the classifier on ktrain and ytrain, and then we call the function test, where test has a predicted output for all the test data. Next, we are trying to get the accuracy. After that, we print out the accuracy. We also try to calculate the error using the number of misclassification, the actual and the expected value, and for each time the predicted and the expected value does not match, we increase the value for the misclassification count. We finally write this all in an output file called a serialized.txt. Now let's see what the output looks like. For this, we go to the original folder and open my terminal. Inside terminal, make sure that you have installed all the necessary libraries that you are importing in the code. So please make sure that you are installing all these libraries, including fs, hog, libsvm, image, ml kernel, and other library. Once that is done, you enter the command node index.js. It takes some time to train. And once the training is done, it will move on to predicting the output. From this we can see that the test size is equal to 50 and the accuracy has come out to be 100. As we have learned in the previous section, that if we get an accuracy that good, there's a very high chance that we are overfitting. So I'll encourage you to try different things and see if we are overfitting or not. In this video, we saw how to use SVM to build an image classifier. In the next video, we'll see ways for making better decisions with decision trees. So I'll see you in the next video. Thank you.